we're going to start talking about fractions now, and so we want to just throw a quick definition out there of what a fraction is. And I know that you've seen a lot of fractions before, but we just want to think about it kind of from the beginning again. So here's a fraction represents some part of a whole number. So when we look at this problem here, and I have the number 2/3, what I'm claiming is that we don't have one whole anything, and what the numerator, which represents the top of the fraction, and the denominator, which represents the bottom of the fraction, what they're actually telling us is this is how many we have, and this is how many we would need to complete the whole. So this is kind of like what we're trying to get to if we want one whole object, and we currently only have 2 out of the 3 that we need. And so when I think about fractions, I always think of it as 2 out of 3. And if we wanted a whole, we would need 3 out of 3. And so you're going to see a lot of fractions thrown at you, but just don't forget the context of what this is actually saying. We're actually saying in this case that we don't have a whole thing. We only have 2 out of the 3 parts that we need in order to make that whole. Right? So that's one possibility. Okay? So the other possibility is maybe we have a mixed number, and what a mixed number is a number that has some whole parts and some fraction parts. Right? So the only thing that I've changed in our problem here is I threw this big 6 into the problem. And so what the 6 means is that we have 6 whole completed objects, whatever they happen to be, okay? And then we have 2 out of the 3 parts we need to make another whole object. So if someone were to come along and bring us that last little piece that we needed in this case, right, this second piece would then become a third piece, and we would say, oh great, we have another whole. We have now 7 whole parts, right? So we're actually saying I have 6 whole pieces, and I have 2 out of 3 of that 7th one that I'm trying to get. So mixed numbers would represent kind of showing the completed parts and showing what we need to make another completed part. Okay? So your third possibility, besides having just parts and having kind of a number that represents the whole parts and the fractions, the little pieces that you need to make another one, is we might instead write an improper fraction. And an improper fraction is a fraction that is bigger than one whole. But instead of us breaking out all of the whole pieces, we're just saying, you know what, in this problem here, we're saying you have 3, for every 3 pieces that you have one complete whole. And we're actually claiming in this case that we have 7 pieces. So if you notice what's happening here is because the numerator is larger than the denominator, we're actually telling people that we have more than we need to make some whole parts. Okay, so an improper fraction is just a different way of writing a mixed number where we don't break out and separate the whole pieces. We just say, you know what, if you want to do that yourself, go ahead, but I'm just going to tell you how many parts you have of the 3s that you need. So we would have to convert it ourselves if we wanted to know how many holes we had. Okay? So what we're going to do is we are going to talk about how do you convert between mixed numbers and improper fractions, because they're really representing the same thing. And if you take a look at my problem here, I could say that these 6 whole numbers, if I were to break them into little pieces, okay, represent some fractions as well, right? And we could write those 6 wholes as fractions that look like this, right? So we need to be able to convert between mixed numbers and improper fractions. So let's start with taking a look at an example where I'm going to give you mixed numbers, and our goal is to write those mixed numbers in improper fraction form. Okay, so I'm going to use the first one to talk about what it actually means, and then the second one will kind of go through the process. Okay, so remember that this 6 represents 6 whole items, and if I'm talking about there being one whole item looking at this fraction here, I'm actually saying that if you had 3 complete pieces out of the 3, that would represent a whole. So if I'm talking about 6 items, I'm actually saying I have 3/3, right? That represents a whole, okay? But I have 6 of those, right? So I'm actually kind of saying there's another 3/3, and there's another 3/3, and there's another 3/3, right? So I actually have 6 of them, okay? These are all the completed ones, okay? And then I have these extra 2 out of 3 that I was not able to complete another whole. So what I would do with this is I'd kind of say I have 3 pieces, I have 6 pieces, I have 9 pieces, this is 12 pieces, okay, this is 15 pieces, and this is 18 pieces, right? So I have 18 pieces out of the 3s in little groups of 3, okay? So that would this 6 really represent 18 out of 3. And if you notice, this is 18 divided by 3, which is actually 6, okay? So I'm saying I have 18 thirds here, and I have 2/3 here, And remember, the bottom number isn't really something that we're going to like do stuff with adding, subtracting, multiplying, dividing. What we're really actually saying with the denominators is just this is how many you need. So the top is saying I have 18 pieces. Right here I'm saying I have 2 pieces. And so really total we have 20 pieces. And remember, the bottom just represents how many, kind of like an indication of how many we need. So I'd say 3 pieces. So as an improper fraction, this 6 2/3 is really 20 thirds. We're saying we have 20 little chunks, right, that you can put together. And if we break them up into like little like piles of 3, okay, we would have 6 whole ones and those extra 2. And so let's talk about just a shortcut. We don't want to have to sit here and write all this out and think about what 6 means in terms of groups of 3. So I'm going to get this, or get rid of this, okay, and let's see how we can turn this into an improper fraction in a little bit easier of a way. So what we're going to do is we're going to take this denominator and we're going to multiply it by that number over there, the whole number. Okay, and if you notice, this is the 18 that we just figured out. Okay, and then if you notice what we did after that was we added 2 more and we got a 20. And so we're going to say multiply 3 times 6 to get your 18 parts that the 6 represents, and then add 2 more for the parts that this little piece represents, and that's how I would get my 20 over 3. Okay, so we don't need to do all of this kind of like manually breaking up into pieces, but it's nice to be able to think about that so you can make sure that your answer makes sense. So for this problem on the right here with the 3.5, we're going to do the same thing. We're going to say multiply the denominator by the whole number. Okay, so that's 6, and then add whatever's the numerator tells you, however many parts are left. So this would be 6 plus 1 is 7 halves, right? And again, the denominator is never going to change because the denominator is always representing how many parts you need to make a whole, and that's not changing when we convert to from one form to the other. So only the numerator is going to change to tell me how many pieces that we have. Okay, so again, multiply the denominator times the mixed number. I'm sorry, multiply the denominator times the whole number, and then add that total with the numerator that you have. Okay, so here's the other possibility. Maybe I give you an improper fraction and your job is to turn it back into a mixed number, and you're going to see in a couple minutes you're going to be asked to do that at the end of the problems that we do once we start multiplying fractions together. So in this case, here's what we do. This fraction bar, okay, is the same thing as asking you to divide. Okay, so I'm really saying do 14 divided by 3. So let's think about that in terms of what we did with whole numbers a little bit ago. We said take 3 and divide it into 14. Okay, 3 goes into 14 4 times. Okay, before I would get too many. If I tried to make this a 5, I would end up too big, right? That would be 15. So 4 times 3 gives me 12. Okay, and I'm going to subtract and I'm going to get 2. And if you notice, there's nothing left to bring down, right? So I'm finished the problem. I'm saying I have 2 items left over, right? And we were writing this before like this. We were saying a remainder of 2. So here's what this represents. We're actually saying, when we say 4 remainder 2, we're saying you got 4 whole groups out of that, and we have 2 out of the 3 that you need to make another one. We don't actually have another full whole. So that's actually what we were just talking about when we talked about improper fractions. That's what an improper fraction represented. In this case, we said the 6 was the whole, the 2 was how many we have left over, and the 3 is how many we need to make another whole. And in this problem here, we have all of those same things. So to take this answer and write it as a mixed number, we're going to say we had 4 whole pieces and we had 2 out of the 3 that we needed to make another whole number. So we're going to put together the whole, the remainder, and the denominator is the divisor, this bottom number, right? Stays as a 3. Okay, so let's take a look at another one. So 17 over 4, I'm going to say 4 divided by 17. Well, that would be 4. Okay, 4 times 4 is 16. And it looks like I have a remainder of 1. And so we're going to, again, take that remainder over the denominator that you started with, which is also this divisor out here. So I'm going to say 4 and 1/4 represents the remainder. Okay, I'm sorry, represents the mixed number. Okay, so now that we know how to convert between those, we just have to use that now to do some multiplication. Okay, so to multiply together fractions, you are going to put them in improper form if they are not already, and then you are going to multiply the numerators together, and you're going to multiply the denominators together, and you're finished. Okay, so in my example here, I'm saying find the product, state your answer as a mixed number. So we're not going to do any, I know that you've seen simplifying fractions, we're not even going to worry about that, we're just going to multiply and turn it into a mixed number. So in this pretty straightforward example, the directions up here say put it in proper form, which this is not a mixed number, so we're good. And then it says multiply the numerators. Well, that's 2 times 1, which is 2. Okay, and it says multiply the denominators, which is 3 times 4, which is 12. So we're saying the product of these two numbers is 2 out of 12. Again, I know you might have seen simplifying. If you want to turn that into a simplified fraction and you know how to do that, that's fine, but we're not requiring it right now. Okay, so here's your next problem. So this says put them in improper form, which I'm looking at these numbers and they are in improper form, and then it says multiply the numerator and the denominator together. Okay, multiply the numerators and the denominators. So this says 11 times 3, which is 33. Okay, and the numerators are 2 times 5, which is 10. Okay, and now here's the extra little thing we have to do here. Our last problem, 2 out of 12, represents, like this is not even one whole number, so this is not an improper answer. Okay, 33 over 10 is an improper fraction because the numerator is bigger than the denominator. So I need to turn this now into a mixed number. And again, the way I'm going to do that is I'm going to say 10 goes into 33. It looks like 3 times. Okay, and when I subtract 3 times 10 is 30. I have 3 left over. So that would be 3, a remainder of 3 out of the 10 that I needed to make another whole number. So I'm going to turn this into the mixed number 3. Okay, and because my remainder was 3, I'm going to have 3/10 left. Okay, so I would say this answer, 33 over 10, as a mixed number is 3 3/10. Okay, so here's our last problem. What happens if we start with mixed numbers? This is the trickiest of them. Okay, your first job is to make them into improper form. So I have to make improper fractions out of these, which we said turn this into 12 plus 1 is 13. So I'd say I have actually 13 over 6. And for this one, I would say 12 plus 2 would be 14 over 3. Remember, denominators stay the same. So I'm going to multiply these values together. And this one's going to be a little bit trickier because when I go across the denominator, I get an 18. That's the easier one. Okay, but when I multiply the numerators, I'm going to have to come off to the side and say 14 times 13, okay, which would be 2 carry a 1, right? That's 12. And I get a 4, right? 3 times 1 plus 1 gives me a 4. And then when I multiply the 1 times this 4 and the 1, I just get a 14. Okay? So when I add down the rows here, it looks like I get 182. So my answer is 182 over 18, but that is not as a mixed number. So I'm going to want to take one more step and turn this into a mixed number. So I'm going to do 18 divided by 182. 18 does not go into 1, right, so I can put a 0 there. Okay, 18 does go into 18, though. It goes in 1 time. Okay, so I'm going to say 1. 1 times 18 is 18. Okay, so I can do my subtraction and say 18 minus 18 is 0. Bring down the 2. And now I'm looking at 18 into 2. Well, I can't do that. This number's too small, so I'm actually going to say my answer here is 1. With a remainder of 2, right? So I'm going to get rid of some unnecessary zeros, right? I don't need this one here, and I don't need what we call leading zeros, okay? So my answer in this case, oh, I'm sorry, I missed up something, okay? So I'm going to say in this case, I forgot that because we tried to do 18 into 2, okay, and we couldn't do it, we do have to note up here above this 2 that we were not able to do it. So it's 10 with a remainder of 2. Okay, so be careful about that. You should have all the way to the end of your number a value above each digit. So I'm going to say 10 remainder of 2. And so that's going to make my fraction here as 10. And 2 out of the 18 that I needed in order to complete my next whole number. I don't have the 11th one, but I have 2 out of the 18 parts, which again, if you want to reduce that and you know how to do it, you are more than welcome. So I'm going to leave this as my final answer, 10 and 2/18. Okay, and we are done multiplying mixed numbers.